Hi, welcome to an Arduino tutorial from RoboJax. My name is Ahmad Shamshiri from Canada. In this video, we're going to learn how we can change the direction of rotation of a DC motor using two relays, independent relays module or one module with two relays. How we can calculate the power rating of a relay: 15 ampere 125 and 10 ampere 250. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. Let me explain it to you. For the DC motor, this is a DC motor, and it has a specific polarity. For example, if I connect this power, don't worry about the wires, and at this location you see that it is now rotating counterclockwise. If I stop it, you will be able to see that this is rotating in this direction. Now you see I've connected this to the black wire. If I switch these wires, you will notice that the rotation, the direction of rotation of the motor has changed. As you can see now, it is rotating at this direction, clockwise. I've set this very slow so you can see it. What it means is that you can change the direction of rotation of a motor by switching the polarity. And I'm going to show you how to use two relays to change the direction of rotation of motor using Arduino very easily. Now let me explain the relay module. I'm going to explain the two module next. So for the relay, we have VCC. This will be connected to 5 volts, and this ground will be connected to ground of Arduino, and this is the N, which will receive signal from Arduino. And we have here an LED. When we have power at these pins, this LED will turn on, telling us that there is power. When the signal receives and relay is energized to make the connection, this green LED will turn on, telling us that it has received signal. We do not worry about the circuits that is driving the relay. I have separate video explaining driving the relay with transistors and other components. The link will be below the video. At this side, for the relay, we have 3 terminals. One is called common, it's at the middle, and then on the right side, this is labeled as NC, normally closed, and this has been labeled as normally open, and which I'm going to show you later. And we use 2 of this, and if you are using this type of relay module, which has 2, that you don't need separate 5 volts for this, 5 volts for this, because 1 5 volts it would be enough for both, and 2. And this module is available on eBay, AliExpress, or Amazon, as well as this one. Here you might get it without this pin, doesn't matter, but for this one we have ground and VCC. VCC is on this side. You will connect 5 volts here, ground here, and this one is called N1, N2. So this is as if this is relay 1, relay 2, and input 1, input 2, and here N1, N2 are here at the middle. And for the 2 terminals for each relay, we have 3 terminals. Here is the 3 terminal for this, and the 3 terminal is for this. Exactly the same. And the beauty of this one is I have separate video explaining this, that it has optocoupler, meaning the circuit will be isolated totally from the other side, and it will be optically coupled. The signal goes via optocoupler device on the other side, so it's much safer. We have a battery. The positive goes through a switch to one terminal, and the negative goes to the other one. So the switch can be either on the line between the positive and the terminal, or we can have it at the negative at the terminal, doesn't matter. And when we connect the positive, for example, to the positive labeled terminal of the motor, because the motor will have a specific label, if you connect that positive to the positive, and negative to the negative, it will rotate a certain direction, for example counterclockwise or CCW. And if you want to change the rotation, you can connect this positive, which was connected before there, now connected here, and the negative you connect it to the positive. Now the rotation will change. Before it was rotating counterclockwise, now it is rotating clockwise. By changing the polarity of the power to motor, we can change the direction. And we cannot connect a motor directly to Arduino, so we can send different signal because we need a driver. But because we are using relay, we will put, instead of driver, we will put a relay here between the Arduino and the motor, and we will be able to control the direction of rotation of motor. Here is how I've connected the relay. We will connect relay 1 and relay 2 in this way. This is normally closed, common, and normally open. These are the 3 pins. This is the coil, which will be either off or will be on. And here I've connected normally closed of relay 1 to normally closed of relay 2 to your power or positive line. And normally open of relay 2 is connected to normally open of relay 1, and it is connected to the ground. Your motor, one of the pin will be connected to common of relay 2, and the other pin will be connected to common of relay 1. And here in this case, relay 2 is off and relay 1 is on. So this coil is on and it has been energized, and this contact is low. This is off and the contact is not low, it's up. And that causes the motor to rotate to the right. The current comes from here, it doesn't go because this is open, there is no connection to this not normally closed pin. So the current comes here through this 2 pins that are closed and goes to the positive, and from this side the negative goes through this 2 contact to the ground, and the motor will rotate to the right or clockwise. And here when you want to rotate the motor not in this direction but into this direction, now relay 2 is on and relay 1 is off. So when the relay 1 is off, the current will come here, passes through normally closed to this pin, and the positive, instead of connecting to the top, now it's connected to the ground. So we have changed the polarity of the motor, and as a result the positive cannot go this way because it's open. It will come through this contact, goes to the negative terminal, and exits from the positive, goes from here to the ground, and this time the motor will rotate to the other direction because this wire is now connected to the ground. Let me explain the wiring for the relay. I've labeled this relay 1, relay 2, and I've taped them together so they're not moving too much. This normally closed pin is connected from relay 2 to relay 1, so they are connected, and this goes to the battery, this wire. And then normally open of this relay has been connected to normally open using this brown wire. And from here I have put another wire from normally open which goes to the battery. So for the battery I have 2 wires, doesn't matter which is which unless your motor is very critical, otherwise just put positive or negative and then you will find out which way to connect it so motor rotates in your desired direction. And here the middle of this is connected to 1 wire of the motor, and the middle terminal, which is common, have been connected to the other wire of the motor. And here is my motor with 2 wires. From ground of Arduino, I've placed 1 wire into this side that has blue color, so this is my negative or ground, and from 5 volts I've taken this orange to the side that is red. So this line will be all 5 volts and this line will have ground if I need it. And here for relay 1, the input will be connected to pin 2, and then for the second one will be the input will be connected to pin 3. And here those 2 pins, blue from relay 1 is connected to pin 2, and green from relay 2 is connected to pin 3. And finally I've connected this red the left side of VCC using red wire and VCC of this using red wire. I've connected to the breadboard. To this red side, and the brown to this side, which is negative. Here for this dual relay, I've put one wire from this using this yellow wire to the other one, from normally closed to the other normally closed. So these 3 pins are for this, 3 pin for this. So the first pin to the first pin, and then one more wire from the same test pin, from the same pin. So this will go to the battery. And here from the normally open of this to the normally open of this, I've put one orange wire, and then from this pin one wire to the battery. So I have 2 wires for the battery, both one from the left side, one from the right side of this common. Now the middle 2 wires are left, so I can connect my motor here and here. These are the 2 wires of my motor. One is connected to the middle of this relay, and the other is connected to the middle pin of this, so the common pins. And here is the motor. This is ground. This is connected to the ground of Arduino using yellow wire, and the last pin is VCC. This has been connected to 5 volts of Arduino. In 1 is for relay 1, and in 2 is for relay 2. And here in 1, green have been connected to pin 2, blue is connected to pin 3. Now let me explain the code. We are defining 2 pins for the relay, relay 1 and relay 2. So you can use any other pin that is available in your Arduino, whatever Arduino Uno, Mega, Nano, Micro, whatever you have. Just put a digital pin here that is available. So I used pin 2 and 3 with my Arduino. And inside the setup, this will run once. We have to define 2 pins as an output. And we use pin mode relay 1. This is as if I type 2. So that variable will be used instead of 2 as an output. So this defines pin 2 as an output, and then this defines pin 3 for relay 2. So relay 2 is 3 as an output. After that, we have to keep the motor off. To keep it off, we write digital write relay 1. This is a pin number, and then we put here high or low. If we put both of them high or both of them low, the relay will be off and the motor will not work. So because I'm using in this case low trigger, I put both of them high, so the relay will be off. And then we define the serial monitor with 9600 baud. If you open your serial monitor by clicking at the tools serial monitor, or you can press Ctrl Shift M or press this icon, so the serial monitor will open. Now the value that you can set is on the lower right side, and it is 9600 baud, and it must match this value, otherwise you will not be able to read the value, the text. And then after that we print this text. LN mean new line, so this prints another text and another new line, and we give the user 2 seconds to read this text, and the setup is ended. So this will run once, and inside the loop the code will run continuously. Now let's see how we can control the motor in a counterclockwise direction, or CCW. We use digital write relay 1, the pin number, as low, and digital write relay 2 high, as I explained in the diagram. So we set one relay as high, the other as low, and this will make the motor to rotate in one direction. Let's call it CCW, because it doesn't matter if you change the wires of the motor will rotate in the other direction. So this will rotate in one direction, and we print this text, and we keep it for 3 seconds rotating in that direction. After that, we want to turn off the motor. Then we use the same code, except relay 1, relay 2, both of them are high. So this will keep the relay or the motor off. We print this text stopped, and then we keep the motor stopped for 2 seconds. I keep it for 2 seconds because 1 second or half a second will take the motor to stop by itself. So 2 seconds, but you can change this value whatever you want. And then now this time we want to change the direction, and if you pay attention, this was low high 1 and 2. Now I'm doing high low. Now the motor will rotate in the other direction for relay 1, relay 2. and we print the text, and we keep it for 3 seconds, and then we stop again the motor for 2 seconds, and then we print this line, so we know the loop is done. For a real world application, you just need to use this or this one or the motor. So you may not use or may use this text or not, but the time is up to you, or maybe continuously based on some trigger or some value, the motor rotation will change. And here is advanced code for controlling motor direction with 2 relay. The difference between this code and previous code is that you can set easily with the level of trigger of the relay module. If your relay is high trigger or low trigger, it will work very easily. This section is the same, and here we have constant integer. We call it trigger type equal low. Mine is low, so you can type low. If yours is high, you can type IGH with uppercase. And these 2 variables are used internally. Do not worry about this. You will see how I use them. Inside the setup, this was exactly the same as before. We check if trigger type is 2 equal sign. This is for comparing this value with low. If it is low, then we say relay on means low and relay off means high. So we use, instead of high and low, we will use this one in the code. And here our relay on will be low and relay off will be high, and then we set the relay 1 using digital write, relay 1 off, and relay 2 also relay off. This relay off mean high in this case. We set the relay 1 using digital write, relay 1 off, and relay 2 also relay off. This relay off mean high in this case. And if the relay trigger type is high, which is not low, else will be executed, and we set this time relay on was low, one is high, and relay off is low. And the same way we use exactly the same as before. We turn off both relays, and then we initialize the serial monitor and print the sticks and wait for 2 seconds. Inside the loop, I have created a function called motor CCW. This will make the motor to rotate in CCW, and we, for whatever time you want, either if you want continuously, remove this, otherwise this will keep it for 3 seconds. And then we have motor stop for whatever time you want. I want it for 2 seconds, so you will see that this will stop the motor. And then motor CW, this was CCW, and motor CW, this will make the motor to rotate in clockwise direction, and then for 3 seconds, and we stop it, and again we print this text, and the loop will go on. Now this motor CCW and CW have been here. Motor CCW use digital write relay, and we use relay on. This is as if I type here pin 2, and then I type here 3, and then here I type high or low depending on a type of relay. So one is high, one is low, and this was cause the motor to rotate in this direction. We print the text. And then for CW, it's just the opposite. Off is up, on is low. Here in the stop, we have relay off in both cases, so both relays are off, and we print the text. So this will make it very clean and easy to use here and control the relay. And here is a demonstration of the motor control. As you can see, we see on the screen counterclockwise, and it is now clockwise rotating. As you can see, this relay is now, when it's off, both of them are off. Now this is on, and the other one was off. So the direction will change. As you can see, the motor is rotating perfectly in CCW and CW. I've reduced the voltage so it makes less noise, and I've applied only 1.5 volts. This can work with 12 volts. Let me increase the voltage. And here is the demonstration of dual relay. As you can see, the serial monitor is also open, and It tells you the value, stopped rotating. As you can see, when it rotates in one direction, only one relay is on. Now this is on and the other one is off, so it rotates in one direction. When it is stopped, both of these relays will be off, and you do need breadboard for the wiring for this. Now let me increase the voltage to 12 volts. This is a 12 volts. Currently I have 1.6 volts. And this is a demonstration of advanced code. You will not see any difference in terms of operation. Thank you for watching. This was how to use two relays to control the direction of DC motor. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it in the comment section below. I try to answer and reply. And if you have not subscribed to my channel, please do so now so you can get updates of my upcoming videos.